All right, so we're going to review for your final exam review, and we'll start off with the very first problem here I'd like to go over. The directions are just going to say to solve. And let's take a look at a problem where it's 7 over x squared minus 5x minus 2 over x minus 5 is equal to 4 over x. When we're doing a problem like this, the first step that we want to do is multiply by the least common denominator. And in order to figure out what that is, we have to factor the denominators completely. So if we're going to go ahead and multiply everything by x times x minus 5, let's just show all our steps. So x times x minus 5 times 7 over x times x minus 5 minus x times x minus 5 times 2 over x minus 5 is equal to x times x minus 5 times 4 over x. I'd recommend that you write everything out so that way you don't miss any terms. And by writing it out, we could see this and this cancels. Whenever you multiply and divide by the same thing, they just cancel each other out. Minus, these cancel and you're just left with 2x. And this is equal to the x's cancel, and it's just 4 times x minus 5. So cleaning this up and distributing, this would be 4x minus 20. You bring the 4x over and you bring the 7 over, you just get x is equal to 27 over 6. And that's how you would solve a rational equation. Another problem like number 2, it's going to say 5 over 3x plus 1 is equal to 3x minus 7 over 3x plus 1. Now this is another rational equation. So what we want to do is we want to multiply by our LCD. So in this case, it looks like it's just 3x plus 1. Another way we could have solved this is a proportion, which means a fraction equal to a fraction. You could have just cross-multiplied and solved. So both will give you the same answer. If we multiply everything by our LCD, 3x plus 1 times 5 over 3x plus 1 is equal to 3x plus 1 times 3x minus 7 over 3x plus 1. The denominators cancel, and this is a much simpler problem. 5 is equal to 3x minus 7. If you add the 7, you just get x is equal to 4. Now, if you had a problem where the denominators didn't factor out or didn't cancel out, what we could do is we could make it equal to 0. That's how we always solve polynomial equations, make it equal to 0. And then we try to solve by factoring. If factoring doesn't work, you could use completing the square. If you don't want to use completing the square, we could just use quadratic formula. So let's try something like this. How about 2x squared minus 5 is equal to x? Like I just said, you want to make this equal to 0 first. So 2x squared minus x minus 5 is equal to 0. And let's check to see if they factor. 2 times negative 5 is negative 10. Numbers that multiply to be negative 10 and add up to be negative 1 don't exist. So it looks like we could either complete the square or quadratic formula. It seemed like you liked quadratic formula better in this class. So if a is equal to 2, b is equal to negative 1, and c is negative 5, what we're going to do is say x is equal to the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. And when you're plugging these numbers into the formula, I would always make sure that you use parentheses, so that way you don't make a mistake with the sign. And we get x is equal to 1 plus or minus the square root of, let me just type this into my calculator quickly. This would be the square root of 41 over 4. And that would be a perfect answer. On the test, the only problems where I would accept decimals are in the word problems. But when we're doing a problem like this, you want to give me the exact answer, which is the simplified radical. Square root of 41, I believe, is prime. I don't think anything goes into that. So that would be the final answer. Next problem, let's take a look at solving multiple square roots in an equation. So 5x plus 6 minus the square root of x plus 3 is equal to 3. When we talked about solving radical equations, what we did is we got the hardest radical by itself, and we moved everything else over to the other side. So we got the hardest radical by itself, squared both sides. Hardest radical by itself, squared both sides. And that's just the process that we do with multiple radicals. So I'm going to bring the square root of x plus 3 to the other side. And we get the square root of 5x plus 6 is equal to 3 plus the square root of x plus 3. And now at this point, what we want to do is square both sides. Let's raise both sides to the second power. And this is 5x plus 6 is equal to, don't forget, we have to FOIL this. Give you a second to get caught up. And what we're going to do is we're going to distribute. So why don't you guys see if you could distribute on your own, and we'll check to see if our answers are correct. All right, so this is going to be 5x plus 6 is equal to 9 plus 3 root x plus 3 plus 3 root x plus 3, and then plus the square root of x plus 3 times itself. When you multiply something by itself, it's the same thing as squaring. So these cancel. And now let's work on getting that next radical by itself. So now we have to get this middle radical by itself. So I'm going to go ahead and subtract x on both sides. I'll subtract 9 on both sides. And I'll subtract 3 on both sides. So we get 4x. And then 6 minus 12 is negative 6 is equal to 6 times root x plus 3. The hardest part is that distributing the radicals. So now what we could do is divide both sides by 6. We get 4x minus 6 divided by 6 is equal to the square root of x plus 3. And then we'll just have to go ahead and square both sides. We'll multiply this by itself. So that radical is gone, but now we just have to go ahead and simplify the left. So if we multiply this out, we'll get 16x squared minus 24 is minus 48x plus 36 over 36, and that's going to equal x plus 3. The way we could finish is multiply everything by 36, or we could go ahead and make it a proportion and cross multiply. So this is kind of a long problem, but I mean, it is what it is. 16x squared minus 48x plus 36 times 1 is equal to 36 times x plus 3. All right, so what we're going to go ahead and do is let's multiply this 36, and we'll get 16x squared minus 48x plus 36, and that's going to equal 36x plus, and then we have to do 36 times 3. So 36 times 3 is 108. So now that we have a polynomial, what we're going to do is make it equal to 0, and we'll see if we could either factor it or use quadratic formula to finish. So I'm going to go ahead and bring the 36x to the other side, subtract the 108, and we get 16x squared, and negative 48 minus 36 is negative 84x, and then 36 minus 108 is negative 72. So this is a monster now. I mean, the numbers are so big. At this point, it might not even be worth your time to try to factor it. So we have the shortcut called the quadratic formula. What I would do to finish this is just go ahead and set A is equal to 16, B is equal to negative 84, and C is negative 72. And then let's just hash this out using the quadratic formula. So x would be the opposite of negative 84, plus or minus the square root of negative 84 squared minus 4 times A times C, all divided by 2A. Bless you. All right, so let's see what this comes out to be here. We just get 84 plus or minus the square root. 84 squared minus 4 times 16 times negative 72 is a ridiculous number. 11,664 divided by 32. Mercifully, that is a perfect square, believe it or not. And that comes out to be 84 plus or minus 108 over 32. And then just finally, to simplify this, 84 plus 108 divided by 32 is 6. And then 84 minus 108 divided by 32 is negative 3/4. So on your final exam, it's not going to be quite as long as this, but it's the same principle, right? You get the harder radical by itself, then you square both sides, get the next hardest radical by itself, and then you square both sides. All right, moving on, we have number 5. And let's write the cubed root of x minus 4 plus 5 is equal to 12. Yeah, I would go ahead and subtract the 5 on both sides. When we're working with radicals, the whole idea is you want to isolate them. So you want to isolate the radicals, so subtract 5 on both sides. We get the cubed root of x minus 4 is equal to 7. And then we could cube both sides to get rid of a cubed root. So x minus 4 is equal to 7 to the third is 343. And then simply add the 4 to both sides. And you get 347. Number 6. What if we had 5 to the 3x minus 1 power is equal to 125 just by itself? So this is an example of an exponential equation where we have the variable as an exponent. The way that we solve problems like this is we want to try to write them as the same base. So 5 to a power should equal 5 to a power. Well, 125 is just 5 to the third. And then we have the same bases. So in math, if the bases are the same, that means that the exponents are the same. So 3x minus 1 is equal to 3. 3x would equal 4, and then x would be 4/3. All right, let's go to number 7. Number 7, we're going to be looking at logarithmic equations. So we have log base 3 of 5x minus 2 is equal to 2. All right, so when we have an exponential equation, what we want to do is get it out of log form and write it as an exponential. So we talked about the crisscross property. 3 to the second power is equal to 5x minus 2. And now that's simple, right? There's no more log there. We could just write 9 is equal to 5x minus 2. Add the 2 to both sides. And then divide both sides by 5. So x would be 11 over 5. All right, next problem, number 8. We're going to be working with negative exponents. So let's say we had 2y to the negative first plus 3x to the negative first, all divided by 12y to the negative second minus 27x to the negative second. We know that negative powers mean that you take the reciprocal, you bring them to the denominator. So we're going to rewrite this as 2 over y to the first plus 3 over x to the first, all divided by 12 over y squared minus 27 over x to the second. So in high school, I teach Algebra 2 regular and I teach Algebra 2 honors. So you guys have that in your schools too? You had different like levels? So yeah, so in Algebra 2 regular, the difference is that that's pretty straightforward. You don't really get fractions in that class. But in Algebra 2 Honors, I tease them a little bit. So because they're taking an honors class, I give them lots and lots of fractions. And I joke with them earlier in the beginning of the year, I tell them that my middle name is fractions. So then, when we get to a problem like this, I'll ask the class, what I say my middle name was? And they are like, fractions. They hate it. They hate doing fractions. But that's what they get for wanting to take an honors course. I have to challenge them. All right, so for a problem like this, we could easily get rid of the fractions by multiplying everything by the least common denominator. So the least common denominator, when you have variables, it's the highest power of the exponent. So it looks like we have x to the second, and then we're going to have y to the second. And then what we're going to do is multiply that times everything on the top and everything in the denominator. So let's just write it all out so we don't make any careless mistakes. X squared y squared times 2 over y plus x squared y squared times 3 over x, all divided by x squared y squared times 12 over y squared minus x squared y squared times 27 over x squared. I'd recommend you write everything out, and then you could simply just cancel out the common factors that you're multiplying and dividing by. So we could cancel out a factor of y with one of these, and we're just left with 2x squared y. Remember, if you cancel one out, you're just left with y to the first. And then over here, you cancel out an x, and you're left with 3x y to the second. And then there's no more fractions in the numerator. And the denominator, the y squareds cancel. And we're left with 12x squared minus 27y to the second. And that would be your answer. So in just one step, we solve this. The one thing that you have to be careful of with this is you want to get rid of the negative exponents, but then once you have fractions within fractions, multiply everything by the least common denominator of the whole thing, and then everything will just cancel out. Nothing's going to cancel further here because the GCF of the numerator is just 1, and there's nothing that can cancel out with that in the denominator, so that would be the final answer. Next, let's move on to number 9. Number 9, ooh, I almost gave you guys the test question. All right, let's try a problem like this. (4x squared minus 25 over 6x squared minus x minus 35 divided by 4x plus 10 divided by 27x to the third plus 343. Well, this is a lot of factoring here. So we talked about factoring is the most important thing that we'll do in this class and even in math. So we have a couple factoring formulas just to refresh your memory. A squared minus b squared would be a plus b times a minus b. And then a cubed plus b cubed. We talked about that formula being SOAP. Same, opposite, always positive. So we're going to need our formula for that. All right, so let's get to factoring. This upper left fraction, this will be 2x to the second minus 5 to the second. So this will factor to be 2x plus 5 times 2x minus 5. And then in the denominator, we're going to have to factor this. I'll just do it off on the side here. 6x squared minus x minus 35 we're looking for numbers that add up to be -1 and multiply to be 6 times 35 or -210. So let's see, 210. If you guys figure it out before me, let me know. 210 divided by 30, 30 and 7. Oh, 15 and 14. I got lucky there. All right, so 15 and 14. So if we go ahead and factor this,
14 minus 2.
Yeah, 6x squared plus 14x minus 15x minus 35. And if we cut it down the middle, we could go ahead and take out a 2x and 3x plus 7. If we take out a -5, we're left with 3x plus 7. So this factors to be 3x plus 7 times 2x minus 5. All right, so that first fraction is completely factored. Let's take a look at this second fraction. The top, we could take out a 2, and we're left with just 2x plus 5. 2x plus 5. And then the denominator is going to be a perfect cube. So the cubed root of 343 is 7. So this would be 3x to the third plus 7 to the third. And then if we factor using the SOAP formula, the sum of cubes, we get 3x plus 7 times 3x squared, opposite sign 2x times 5, and then always positive 5 squared. And then when you divide, that's the same thing as multiplying by the reciprocal. So let's see here. We can go ahead and cancel these out. We get 2x plus 5 over 3x plus 7. And we're going to be multiplying by 3x plus 7 times 9x squared minus 10x plus 25, all divided by 2 times 2x plus 5. These factors cancel, these factors cancel. So it looks like all we're left with is 9x squared minus 10x plus 25 divided by 2. That would be our final answer. Yeah, question?
When you factored up, I think the 27 cubes.
Yeah.
What did you get?
Yeah, so this turns into this. So this is the 3x to the third is the a term. The 7 is the b term. So when we go to do this, it's going to be the a plus b. And then a squared, opposite sign, ab, always positive b squared. Oh, yeah, sorry, I made a mistake. That 5 is supposed to be 7 squared. All right, so let's just go ahead and fix this. Thank you, Alyssa. All right, 7 squared is 49. So 9x squared minus 14x plus 49. All right, and that would be our answer. Yeah.
That 2x plus 3x.
Which 2x?
The one in the cube that you just did.
Yeah, sorry, long day. So 3 times 7 is 21 then, right? Good. So a lot of moving pieces. The more you show your work, the less likely you'll make mistakes. But if you do make mistakes, they give out a lot of partial credit. So there's no pressure with any of this stuff. All right, let's move on to number 10. For problem number 10, we are adding rational expressions. So we'll have a problem like this. 3x over x squared plus x minus 2 plus 2 divided by x squared minus 4x plus 3. Now, in order to add rational expressions, they have to have the same denominator. So first, let's see what the denominators are once they're factored out. So it looks like we have x plus 2 and x minus 1. Those would be the factors for the first fraction. This would be x minus 3 and x minus 1. So in order to combine our fractions, let's figure out the least common denominator. We definitely need an x minus 1 because both fractions have that. One fraction has an x plus 2, which means both fractions need an x plus 2. So I'm going to go ahead and multiply the top and bottom here by x plus 2. And then this fraction has an x minus 3, the one on the right. So both fractions are going to need an x minus 3. So I'm going to go ahead and multiply the fraction by whatever's missing. So the one on the left has an x plus 2 and an x minus 1, but it's missing the x minus 3. So now we have 3x times x minus 3 divided by x minus 3 times x plus 2 times x minus 1 plus 2 times x plus 2 divided by exactly the same denominator. Because they have the same denominators, that means that we can go ahead and combine those fractions. And we could go ahead and combine the numerators too. So it's going to be 3x times x minus 3 plus, and then 2 times x plus 2. Just be careful, if this was the exam and this was a minus sign, you would be subtracting this entire term. So you would have to put that whole thing in parentheses. All right, so let's finish this up here. 9x, or let's see, 3x times x is 3x squared minus 9x plus 2x plus 4 divided by x minus 3 times x minus 1 times x plus 2. And then combining our like terms, 3x squared minus 7x plus 4 divided by x minus 3, x minus 1, and x plus 2. When you get a final answer, it might make sense to try to factor it to see if you could simplify it further. So 3 times 4 is 12. Numbers that multiply to be 12 and add up to -7 are -3 and -4. So it looks like we could factor this even more and then try to simplify our final answer. So I'll do this quickly here. 3x squared minus 3x minus 4x plus 4. Cut it down the middle, take out a 3x. So 3x minus 4 and x minus 1. So the numerator is 3x minus 4 times x minus 1 divided by the denominator, It's like the problem that never ends. The x minus 1s do cancel, so it's a good thing that we factored so we could see that it could further simplify. And this would be our final answer. So as long as you show your steps and you just keep trying to factor, you should be okay. There's a lot of moving pieces, but really all it is just factoring. All right, so at this point in the review, we're going to shift over to talking about radicals and rational exponents. So let's say we had a problem like this. How about eight a to the 1/3 power times 2a to the 2/3 to the 3rd power. First thing we do is, when we're talking about order of exponents, we do PEMDAS. Parentheses, exponents, multiplication, division, addition, and subtraction. So let's go ahead and distribute the exponents. This is 8 to the 1/3, a to the 1/3, and then 2 to the 3rd, a to the 2nd. If you distribute 3 times 2/3 is just 2. One-third power means we take the cubed root. So this would be the cubed root of 8 times the cubed root of a to the 1st times 8 times a to the 2nd. Cubed root of 8 is 2. So let's say we have 2 times the cubed root of a times 8 times a to the 2nd. Two times 8 is 16, and then 16a to the 2nd cubed root of a, and that would be our final answer. Yes. Okay, good. Good. So that's number 11. Let's go ahead and take a look at number 12. All right. All right, so number 12, we have the cubed root of 81, x to the 5th, y to the 6th, z to the 13th. And then we'll go ahead and take the cubed root of 81 and we'll go ahead and take the cubed root of x to the 5th, the cubed root of y to the 6th, and then the cubed root of z to the 13th. And then we'll just have to simplify each of these. All right, so the cubed root of 81, we talked about a few different ways to do that. We could find perfect cubes, or we could just go ahead and use prime factorization. So let's see, I'm going to write this as 3 and 27. 27 is the same thing as 3 and 9, which is 3 and 3. So we're looking for groups of 3 because it's a cubed root. So here's a group of 3s. we get 3 times the cubed root of 3. That's how we talked about simplifying cubed roots. Now, when it comes to variables, we talked about there's an Ottino theorem that I shared with you. The Ottino theorem is if you have a fraction. So if we did, let's say, x to the 5 over 3. 5 over 3 as a mixed fraction is 1 with a remainder of 2. So when you have a mixed fraction like this, what we could do is we could write it x to the a power and then the c root of x to the b. So we talked about those are where we put those numbers. So this just turns into x to the first times the cubed root of x squared. And we have y to the 6 over 3 is just 2. And then we have 13 over 3, which as a mixed fraction is 4 1/3. So we get z to the 4th times the cubed root of z to the 1st. We go ahead and we multiply everything on the outside. So your final answer would just be 3xy squared z to the 4th. And then we have the cubed root of 3x squared z. All right, number 13, we're just going to reduce radicals. So 13, it's going to ask you to simplify. There's a couple different problems here. We have just regular real numbers, and then we have some complex numbers. So let's try something like this. 3 times the square root of 128 plus 2 times the square root of 18 plus 2 times the square root of 32. So let's go ahead and simplify this. The square root of 128 is the same thing as the square root of 64 times the square root of 2. And then don't forget the 3's here. So we have 3 times 8. 24 root 2 is what that simplifies to. The square root of 18 is the same thing as the square root of 9 times the square root of 2. So 2 times 3 is 6 root 2. And the square root of 32 is the square root of 16 times the square root of 2, or 4 times 2, which is 8 root 2. And then when we are simplifying radicals, we add all the outside numbers as long as the inside or the radicands are the same. So 24 plus 6 is 30. 30 plus 8 is 38 root 2. With complex numbers, say if we had a problem like this, square root of negative 25 plus the square root of negative 36 minus 2 times the square root of negative 4. In order to simplify this, first thing we have to do is take out the negative from the radical. So this is the same thing as just negative 1 times the square root of 25, or 5i. Square root of negative 36 likewise is 6i. And then 2 times 2i would give us negative 4i. So because we have 3 of the same terms, we can go ahead and combine those. 5 plus 6 is 11. 11 minus 4 is 7i. Number 14, you are asked to rationalize. So we have a fraction like 4 over 2 minus the square root of 3. And we talked about this is almost like that game Whack-A-Mole, where if you just multiply top and bottom by the square root of 3, the radical just shifts to one side or the other, which is where we used that word conjugate. So 2 plus root 3, this is called conjugate because we changed the sign in the middle. It's going to work the same for our next problem too. I mean, maybe we could even get started with the next problem. What if I had 4 over 2 plus 3i? It's the same thing. So anytime you have a radical in the denominator, we want to multiply by what's called the conjugate. Conjugate just means you change the sign in the middle. All right, so we'll just go ahead and finish this up. I'll put these in parentheses and I'll distribute. So this is 8 plus 4 root 3 over 4 plus 2 root 3 minus 2 root 3 minus the square root of 9. The middle terms cancel, and we would just get 8 plus 4 root 3 over 4 minus 3, which is just 1. So your best answer would be 8 plus 4 root 3. That would be the best answer for a problem like this. The problem below it, we're still going to use the conjugate. We're working with imaginary numbers, but we know that I is really just another square root. So in the numerator, we're going to have 8 minus 12i over 4 minus 6i plus 6i minus 9i squared. So we get 8 minus 12i over just 4 minus 9 times negative 1. Remember, I squared is the same thing as negative 1. So we just get 8 minus 12i over 4 plus 9, which is just 13. That would be the best answer here. You do have a problem where it's just a huge quadratic. So let's take a look at something like this. The way it's written in the final, I don't know why they did it like this, but they're counting it as 2 problems. So they just say problem 16 and 17. It looks like this. It says given let's use this one. I'll just make one up. Okay, so let's say given f of x is equal to 3x squared minus 2x plus 1. It's going to ask you for 6 different things. First thing it'll ask you for is to find the vertex. And we talked about getting the vertex a couple different ways. One way is by completing the square. I don't really think anybody here wanted to do that. It's just a lot of steps and it's a lot to just keep track of. The easiest way to get the vertex is to do the opposite of b over 2a and then just plug that value in to get the y value of the vertex. So I could show you both methods, but I'm pretty sure most of you will prefer to use the second technique. So using negative b over 2a, if a is 3, b is negative 2, and c is 1. So the opposite of b would be the opposite of negative 2, all over 2 times 3. Which is just 2 over 6, or 1/3. So the way that we find the y value is we just plug 1/3 in for all the x's. And let's see what we get. So if we let 1/3 be the x value, and I'm just going to plug it in for all the x's here. I'm getting 2/3 would be the y value. So that would be the vertex. That's the first step. Completing the square, what we do is we isolate the variables, factor out the leading coefficient, and then we take half of the middle and square it. So half of 2/3 is 2 over 6. 2 over 6 squared is 1/9. And then when you add values to an equation, you have to balance it by subtracting it. So 1/9 times 3 is 3/9, or 1/3, which we have to subtract. So this is going to factor to be y is equal to 3 times x minus 1/3 squared plus 2/3. This is moving the graph to the right and then up, which gives us the same exact vertex of 1/3, 2/3. So you're not asked a specific way to find this, but if you really wanted to, you could use both techniques just to make sure that you're right. Second thing they ask you to do is to find the y-intercept. The way that we get the y-intercept is we make x equal to 0. So we have 3x squared minus 2x plus 1. And then we put 0 in for all the x's. So the y-intercept would be 1. I'm going to start graphing this. The y-intercept is 1. I'm going to label it. And the vertex is at 1/3, 2/3, which is maybe over here somewhere. Third step is we want to get the x-intercept. The way we get the x-intercept is we make y equal to 0 and solve. So 3x squared minus 2x plus 1 is equal to 0. We could try to factor, so numbers that multiply to be 3 and add up to be negative 2. Yeah, 1 and negative 3 wouldn't multiply to give you positive 3. So I'm not sure this is going to factor. So let's just go ahead and use quadratic formula. So we're going to take the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. Which is 2 plus or minus the square root, let's see, negative 2 squared minus 4 times 3 times 1 is just negative 8 over 6. Square root of negative 8 is the same thing as square root of 4 times the square root of 2, or just 2i root 2 over 6. We can go ahead and divide the numerator and the denominator by 2 to fully simplify. And we just get 1 plus or minus I root 2 over 3. Which makes sense too, because if you look at the graph, if the vertex is 1/3, 2/3, it's going to open up, so it never crosses the x-axis. So we would imagine that the x-intercepts are imaginary. A couple other things it asks us for. It asks us for the domain. Remember, we said we only have issues with the domain if x is in the denominator or if it's inside a radical, so we have neither here. So the domain would be from -infinity to infinity, so all real numbers. And then as far as the range, when we are writing an interval notation, the low number goes on the left and the high number goes on the right. So it looks like the lowest y value this is going to go is 2/3, and then it goes up forever. So we just make sure that we put that bracket to include 2/3. All right, so there's a couple more problems here. So we have a domain problem, which is pretty simple, and then we have some word problems. So problem number 18, it just asks us to find the domain of f of x is equal to 2x minus 7 over x squared minus x minus 12. Remember what we said, when we're looking at domain, we're only focused on the denominator. And if there's a radical, we're looking to make sure that that radical is greater than or equal to 0. So we don't care about the 2x minus 7, but we know this denominator, x squared minus x minus 12, can't be 0. So let's go ahead and solve for it. And then the domain would be values where x is not those numbers. So if you factor this, this is just x minus 4 times x plus 3, giving us 4 and -3. And remember, those are the values that x can't be, because those make the denominator 0. So on a number line, we'll go to -3, and we'll use any number up to that between -3 and 4, and then greater than 4. So the way that we write this in interval notation is we say from -infinity to -3, in union with -3 to 4, and then in union with from 4 to infinity. All right, so then the rest of your final are word problems. So on your review, you have 8 problems. On the final, there are 3. And the final, you are asked to choose 2 out of the 3 problems. So we have a little bit of time left. We could talk about some problems. If I were you, I might look over. So let's say we had a problem like this. Let's say that bacteria grows according to the formula y is equal to 130 times 5 to the -0.2 t. So this is an equation to find the population of bacteria. And then you are asked for 2 things. First one is how many bacteria were present at the beginning. Well, in the beginning, what would t equal? 0. So all we have to do is just plug 0 in for time, and we get y is equal to 130 times 5 to the negative 0.2 times 0 power, or 130, anything to the 0 power is 1. So the initial population is 130. Then second part, how many bacteria were present 3 hours into the experiment? Well, 3 hours, so t is 3. So if you can, why don't you take out your calculators, and let's just make sure we can plug this in, because really that's all this is. You don't want to get it wrong because you plugged it into your calculator. So we get y is equal to, if t is equal to 3, 130 times 5, and in our calculator, okay, so 130 times 5 to the power, and then we're going to put negative 0.2 times 3. So you have to type it in exactly like this. So 130 times 5 to the power of negative 0.2 times 3 is 49, call it 49.5. I mean, you can't really have half of the bacteria, so we'll just call it 49. All right, a couple other word problems here I would focus on. So one says that Jennifer can plant a garden in 6 hours and working with Brad, it takes 4 hours. How long would it take Brad working by himself? So this is an example of a work equals rate times time problem. Very similar to the distance equals rate times time problems. They're all kind of the same. So we have Jennifer's work, we have Brad, and then we have together. And work is equal to rate times time. The difference is when you're working together, you're adding the two rates. All right, so let's start with Jennifer. It looks like she could do one garden in 6 hours. We have no idea how long it takes Brad to do it, probably a long time here. So we'll say Brad 1 is equal to R times T. We don't know how long that's going to take, but we know that together 1 is equal to Jennifer's rate plus Brad's rate times 4 hours. So we just have to do some moving around of the variables. Looks like Jennifer's rate would be R is equal to 1/6. So it's a sixth of a job in 1 hour. If we do the same thing with Brad, it'd be 1/T. So now all we have to do is just plug those into the together formula and solve for Brad's rate. So we have 1 is equal to 1/6 plus 1/T times 4. And now we just have to go ahead and distribute the 4. So 1 is equal to 4/6 plus 4/T. And this is a good example when we need a least common denominator to multiply everything by that. So looks like our least common denominator definitely needs a t in it, and we also need a 6. So I'm going to multiply everything by 6t. And let's see what we get. 6t is equal to 4t plus 24. So 2t is equal to 24, or t is equal to 12. So it sounds like Jennifer is a much more experienced gardener than Brad is.